A simple manometer is containing mercury used to measure the pressure of water flowing in a pipeline. The mercury level in the open tube is 60 mm higher and higher than the left limb. If the height of the water of the left tube is 50 mm, determine the pressure in the pipe in terms of head of water. Given height mercury level in the open tube, then in the left tube. Okay, H2 is equal to 60 mm. H2 is 60 mm and H1 is 50 mm, H2 is equal to 60 mm. Let H is pressure in the pipe in terms of head of water. So we know that pressure head in the left limb above ZZ is equal to H plus S1, H1 is equal to H plus S1, H2. Okay. Consider the pressure in the left side, H plus S1, H1. Okay. What is the S1 specific gravity of the pipe liquid water? Water specific gravity is 1. So H plus 1 into 50. We got H plus 50 meters of water. And the pressure held in the right limb above ZZ. S2 H2 is equal to 13.6. S2 is the specific gravity of mercury. Specific gravity of mercury presented in the left limb. Right limb. So if you simplify it to 13.6 into 60, we will get 816 mm of water. So if we equate it, H plus 50 is equal to 81.6, we will get 860 minus 50. We will get 766 meters of water. In this way, we will find out. This is the problem of negative pressure. Understand? See, a simple manometer containing mercury was used to find the negative pressure in the pipe water as shown in figure. The right limb of the manometer was open to atmosphere. Find the negative pressure below the atmosphere in the pipe. If the manometer reading are given in the figure. See what is the data given? H2 is equal to 50 mm, H1 is equal to 20 mm, S1 is equal to 1 because of the water, and S2 is equal to 13.6 because of the manometric fluid, mercury, and H is the pressure in water in the pipe. So what is the negative pressure equation, or the pressure on the left side? H plus S1 H1 plus S2 H2 S2 H2 H plus 1 into 20 plus S2 13.6 into 50. If we simplify it, we will get H plus 700 mm of water, or H plus 7 meters of water, and the pressure head in the right limb above ZZ is equal to 0. So left side pressure is equal to right side pressure. H plus 7 is equal to 0. Therefore, H is equal to minus 7 mm of pressure. So it is a negative pressure. This is the vacuum pressure. Pressure measured on less than the atmospheric pressure. And also this is one more problem. Heights given 3. Okay, shows a figure shows a conical vessel having an outlet at A to which huge manometer is connected. The reading of the manometer given in the figure shows when the vessel is empty. Find the reading of the manometer when the vessel is completely filled with water. See, manometer reading when the vessel is empty. Okay, H2 is equal to 200 mm, that is 0.2 meter. S1 is X1 because of the water, and S2 is the 13.6 mercury. Let H is the pressure head of the oil in terms of head of water. First of all, let us consider the vessel is to be empty at ZZ section. We know that pressure in the right limb is equal to S1 H1. Pressure head in the right limb. S1 H1 is equal to 1 into H. That is equal to H meters of water. Pressure head in the left limb is equal to S to H2, 13.6 into 0.2, that is 2.2 meters of water. Since the pressure in both limbs above the ZZ diagram are equal, therefore equating both, we will get H is equal to 2.72 meter. Now consider the vessel to be completely filled with water. As a result of this, it is mercury level go down X meters in the right limb and the mercury level go up by the same amount in the left limb. Therefore, total height of the water in the left limb, right limb is X plus H plus 3 is equal to X plus 2.72 plus 3. So we will get X plus 5.72 meters. So we know that manometer reading in this case is 0.2 plus 2x. And the pressure head in the left limb is called 13.6 into 0.2 plus 2x. So 2.72 plus 2.2, so 27.2 into x. By equating these two equations, we will get x plus 5.72 is equal to 2.72 plus 27.2 x. So if we simplify it, we will get x is equal to 4.430 or 430 mm of water. Always equating left side pressures to the right side pressures. That is the only thing. Micromanometer. It is a modified form of manometer in which cross-sectional area of one limb or left limb is much larger, about 100 times than that of the other limb. So micromanometer is used to measuring the low pressures where the accuracy is important. What is meant by micro? Micro means small. By using micromanometer, we can measure the very less pressures with a high accuracy. So this is the micromanometer symbol. Left side is very much bigger than the right side tube diameter. Understand? There are two types of micromanometers. Vertical tube micromanometer, inclined tube micromanometer. Vertical tube micromanometer. Now consider a vertical tube micromanometer connected to a pipe containing light liquid under a very high pressure. Okay. Vertical micromanometer pipe is containing light liquid under very high pressure. The pressure in the pipe will force the light liquid to push the heavy liquid in the basin towards downwards. Due to the larger area of the basin, the fall of heavy liquid level will be very small, larger area because this downward movement of the heavy liquid in the basin will cause a considerable rise of the heavy liquid in the left limb. So this is thing. So being water is flowing at a high pressure. What is happening? It pushes the manometric fluid to move in the right side. Right side tube diameter is very less, so it moves at a height. Whereas in right side, the left side, area is very small. Area is very big. The rise is very small. That may be represented with the delta. Let us consider datum line ZZ corresponding to the heavy liquid level before the experiment. Delta H is the fall of heavy liquid level in the basin. H2 is the height of the heavy liquid in the right limb. H is the pressure in the pipe expressed in meters of head water. Capital A is the cross-sectional area of the basin. Small a is the cross-sectional area of the tube. S1 is the specific gravity of the light liquid. S2 is the specific gravity of the heavy liquid. So we know that the fall of heavy liquid level in which the basin will cause a corresponding rise or rise of heavy liquid level. ఒక 10 నిమిషాలు అది ఎక్కడ పెట్టాలి తాళం వేసి ఒక 10 నిమిషాలు ఉండమ్మా 10 నిమిషాలు ఆపేసుకొని వచ్చేస్తా నీకు బండి ఉందా బస్సులో అవుతున్నా సరే నేను దింపుతాను నేను ఓకే Okay, we know that the fall of heavy liquid level in the basin will cause a corresponding rise of heavy liquid level. So, A into delta H is equal to AH because volume of the water is same. That is why the A into delta H is equal to A into H2. So, therefore, delta is equal to H is equal to small a by capital A into H2. Now let us take the horizontal surface in the basin at which the heavy and light liquid meet as a datum line. We also know that the pressure in the left limb and right limb above the datum line are equal. So the pressure in above the datum line ZZ is equal to H plus X S1 H1 plus S1 into delta H meters of water. Similarly, pressure in the right limb above the datum line S2 H2 plus S2 delta H. Okay, if we equate these two, we will get H plus S1 H1 plus S1 delta H plus S2 delta H plus S2 delta H. Okay, so from here we can write H is equal to S2 H2 plus S2 delta H minus S1 H1 minus S1 delta H. So here we make it common. S2 H2 as well minus S1 H1 plus delta H common. S2 minus H1. So from first equation we can write delta H is equal to capital small a by capital A into H2. Next slide. If the cross-sectional area of the basin is too larger than the tube, the ratio of small a by capital A is extremely small, very negligible value. So we can neglect it. If we neglect that two terms, we will get H is equal to S2 H2 minus S1 H1. H is equal to S2 H2 minus S1 H1. See, this is the inclined manometer. This tube is inclined, making it an angle alpha. Okay, and L is the length of the manometric fluid presented in it, and height H2 is the height of the manometric fluid above the datum. Okay. See, this is a problem of simple micromanometer. In order to determine the pressure in a pipe containing liquid specific gravity at point A, micromanometer was used. The ratio of area of to that the limb, the ratio of area of the basin to that the limb is 50. Find the intensity of pressure in the pipe for the manometer reading as shown in figure. See, manometer height of the column of the manometric fluid in right limb is 200 mm. Understand? And height of the light liquid in the left limb is 100 mm. See what is the data given? S1 is equal to 0.8, capital A by small a is equal to 50, H1 is equal to 100 mm, H2 is equal to 200 mm, and S2 is equal to 13.6 for mercury. Okay, we know that the pressure head in the left limb above ZZ is equal to, what is the thing? H plus S1 H1 plus small a by a into S1 H2. This equation we derived in previous slide. H plus S1 is 0.8. Okay, H1 is 100 plus 1 by 50. Why? Capital A by A is equal to 50. So, small a by capital A is 50. So, 1 by 50 into small S2 0.8, H2 200. So, if you simplify it, we will get H plus 83.2 meters of water. And the pressure head in the right limb is S2H2 plus capital small a by capital A into S2H2. That is equal to 13.6 plus 200 into 1 by 50 into 13.6 into 200. Okay. Since the pressure in the both limbs are above the ZZ atom is equal, equate these two equations. So H plus 83 point is equal to 2774.4. Understand? So finally we will get H as 2.6912 meters of water. Understand? So this height of the liquid column we got it. Therefore pressure head is equal to P is equal to rho C H or WH. W, what is the value? 9.81 into specific weight given in the problem. Otherwise, we can put it as a rho G 9.81 into 1000. So we will simplify it and directly this value given 2691.2. So we simplify it, we will get 264 kilonewton per meter square. G is rho G, rho is equal to 1000. Understand? G is 9.81 and this pressure is directly written. So this value into 1000 we will get. Understand? So 1000 can be written as kilo. Therefore 26.4 kilonewton per meter square. 26.4 kilopascal. Like that we can express. One more thing, differential manometer. This device is used for measuring pressures between 2 points of a pipe or two different pipes. Okay, there is two different pipes are there. Understand? So we are measuring the pressure difference between these two pipes. That is why this manometer is called as differential manometer. Let us take the horizontal surface ZZ. Above the heavy liquid and light liquid meet the left limb. H is the difference of the levels of heavy liquid in the right and left limb is known as the reading of the differential manometer. H is the pressure head in pipe A, HB is the pressure head in pipe B. S1 is the specific gravity of the liquid in pipes and S2 is the specific gravity of the heavy liquid. We know that the pressure head in the left limb is HA plus S1H plus H. How we are writing this? This one, pressure head in the left limb, H plus H1 capital H plus S1 plus small h. Okay, HA plus S1 into capital H plus small h, that is called HA plus S1H plus S1 small h. Assume it as equation 1. And the pressure head in the right limb is equal to HB plus S1H plus S2H. how we return? See this one. HB, pressure in the pipe B is HB plus S2H plus HB plus S1H plus S2H. Okay, in this way we have to represent. See, right, HB plus S1H plus S2H. Understand? So pressure head and the both limbs above the datum ZZ is same. So HA plus S1H plus S1 capital H plus S1 small h is equal to HB plus S1H plus S2H. Here S1H will be gets cancelled. So HA minus HB is equal to S2H minus S1H. H is same. Okay, HA minus HB is equal to H into S1 minus H2. In this way, we will find out the pressure difference between the two pipes. Okay. Now consider a differential manometer whose two ends are connected to two different pipes A and B and containing different liquids at different levels. Let us assume the pressure at the point A is more than the pressure B. A little consideration will show that the greater pressure at A will force the heavy liquid to move downwards. This downward movement of the liquid in the left limb will cause a corresponding rise of the heavy liquid in the left limb, right limb. The horizontal surface at which heavy and light liquids meet in the left limb taken as a datum line. In this case, let ZZ be the datum line. Okay, and this is the one different case. Understand? What is this? These two pipes are at different levels. That is a thing. So we can measure the pressure difference by using differential manometer at same level or at a different level pipes. Same. Let H1 is the height of the liquid in the left limb above the datum line, and H2 is the difference of the heavy liquid in the right limb and left limb. H3 is the height of the liquid in the right datum line. HA is the pressure head in the pipe A. HB is the pressure head in the pipe B. And S1 is the specific gravity of the liquid in the left pipe. S2 is the specific gravity of the heavy liquid, and S3 is the specific gravity of the liquid in the right pipe, that is the pipe B. So once again, after discussing this, H1 height of the liquid presented in the left limb, H2 is the height of the monometric fluid, and H3 is the height of the column presented in the right limb or liquid pipe B column. Understand? So HA is the pressure head in pipe B A. HB is the pressure head in pipe B. Okay. See this. We know that the pressure in the left limb above the datum is HA plus S1H1. And pressure in the right limb above the datum ZZ is S2H2 plus S3H3 plus HB. Understand? So by equating these two, we will get HA plus S1H1 is equal to S2H2 plus S3H3 HB. So pressure difference is equal to HA minus HB is equal to S2H2 minus plus S3H3 minus S1H1. In this way, we will determine the pressure difference between two different pipes. Okay. In next class, we will see the problems on this differential manometers. Now the time is very much. 5:25 p.m. Okay, college time over. Tomorrow we will meet you again. Thank you. Now you can leave.
Thank you, sir.
Okay, ma. Right. Thank you.